Okay, 7.2, applications of the normal distribution. All right, remember, if x is a normally distributed random variable, the area under the normal curve represents the proportion of a population with a certain characteristic or the probability that a randomly selected individual from the population has the characteristic. So then the question becomes, how do I find the area under that curve? We're going to use z-scores to help find it. Okay, so suppose that the random variable is normally distributed. I have to know that. I have to know it's normally distributed or none of this applies. Okay, with a mean mu and a standard deviation sigma, then we have a formula here that we can plug into that gives us our z-score, right? What this does is it shifts all our information around. Remember, if it's normally distributed, it's a symmetric bell-shaped curve. And, all symmetric bell-shaped curves are basically the same. Some are skinnier, some are shifted over right or left. So what this does is it shifts our particular information into a bell-shaped curve where the mean is 0 and the standard deviation is 1. So that's all we're doing, right? It's just shifting our information to a little bit easier bell-shaped curve. Okay, so this is really powerful for us. Okay, let's see. Okay, I think there was something else here I needed to say. Well, if I think of it in a minute, we'll bring it up. Okay, so right now, if I have a z-score, right, if I can compute all my basic information, my raw data, so to say, okay, into z-scores, we have a table that we can use. And by the way, you can find that table in your course documents, okay, if you need to refer to the specific table. And it's the standard normal distribution table. Okay, so this is what the standard normal curve looks like. Your mean is 0 and standard deviation of 1. Okay, this text has a habit of only including the first standard deviation, but remember, okay, that 3 standard deviations is 99.7% of the graph, not 100%, right? These don't really ever meet, okay, but really, the basic bell-shaped curve has our 3 standard deviations drawn in. Okay. IQ scores can be modeled by a normal distribution that has a mean of 100 and standard deviation of 15. So any individual whose IQ score is 120 is 1.33 standard deviations above the mean. And where they got this is by plugging into that formula, right? Here's the mean. Sorry, that's not the mean. Here's the value that we're interested in, our x value, right? And we subtract the mean, you divide by the standard deviation, and that's where they came up with that 1.33. And then once you know your z-score, you pull up your standard normal distribution table, and we always round z-scores, round them to 2 decimal places. Okay, so we'll look over here until we see 1.3. Okay, 1.3, 1.3. And then this represents 1.30, 1.31, 1.32, 1.33, right? And here we are. It's as simple as that. Now we know that the probability of a person having an IQ of 120 is 0.9082. Okay, let's talk a little bit more about this before we go on. So really, we said earlier, anytime I know it's normally distributed, I'm going to draw this curve, right? Where this is our mean. Okay, and then we've got these 3 standard deviations. Sorry about my drawing here. Okay, so we're going to add 15. Add 15 3 times. Barely have room here. And if you're, kind of following the method in this book, they'll let you get by with just adding it one time for the most part. Then we're going to subtract 15 3 times. Okay, so now the value we're looking for is 120. And that's kind of right here, right? 120. Okay, also, if we were to compute this with now this is our raw data here, and if we put our z-scores on here, it would look like this. So it might be useful to you to put both, right? Sometimes you're only going to have your z-score, so you can't put both. But if you have your actual data values, it might be helpful to put those, and then in addition, your z-scores. All right, so what we want to understand about what this table is telling us is that it is telling us, remember we have 2 interpretations. It's telling us the area under the curve to the left. Every value in the table is to the left of our value under consideration, right? As a z-score, remember this is 1.33. Okay, or it's telling us the probability that a person's IQ scores 120 is 0.908, about 0.91, okay? And in addition to that, that means that this person has scored 91% higher than all of these people. So that also means, hey, he's in the 91st percentile. His percentile ranking is 91. He's in the 91st percentile. So notice how all of that is related. Okay. So, does that make sense? Because we want to think about that, these steps every single time. Now, if we would have needed, see if I can get a different color. If we would have needed this area, what's the probability that a person scores that a person's IQ score is more than 120? Okay, then we're just going to use our complement because the table is always less than. So if I want to know it's more than 120, so the probability that X is more than 120 is 1 minus the probability that X is less than 120, which is 1 minus 0.9082, right? Whatever that is. Okay, we're going to use this chart a lot, but if we have our mean and standard deviation, we can also use our calculator. So if we have a mean and a standard deviation, we can also use our calculator. Okay, so let's see how we would do that. And again, the basic steps are in the technology tips from the text under binomial, no, not binomial, normal distribution. So let me get my calculator out and we'll go over it right quick right here. Okay, so what you do is you hit that second vars again to go into your distribution, right? Whatever's above that. You go down to the normal CDF, the cumulative one that we did, okay? And you're going to put four entries after your parenthesis. One's going to be your low value, one's your high value, and this is what you're calculating in between. And then you put your mean and your standard deviation. Now, because we wanted to know the 120 is just everything less than, I'm going to put 0, 120. If I wanted to know what's the probability their score was between 100 and 120, I'd put 100, 120. But just 120, right? That's 0 to 120. And then I'm going to put a comma. And then I'm going to put the mean, 100, comma, standard deviation, 15, close your parentheses and hit enter. And we got, doing it with our calculator, it gives me 0.9087888. Notice if I round this to 4 decimal places like we have from our chart, 0.9088, and our chart gave us 0.9082. That is because, right, the difference is because the rounding that the z-score, we always round this z-score to 2 decimal places. So anytime you do some rounding, it affects your answer. So that's why we try to leave several decimal places. So you may get a slightly different answer depending on whether you're using the table or your calculator. But notice they both round to 0.91. Okay, so let's look at that a little more. Okay, find the area under the standard normal curve, and I got to know this, I got to know normal to the left of z equals, I can't use my calculator on this one, right? So I have to know the table too. I can't use my calculator, it's just giving me z. To use my calculator, I got to know my mean and my standard deviation. Okay, so I want to the left when z is negative 0.38. So 0.3, and then I'm going to go over to 0, 1, 2, 3, 4, 5, 6, 7, 8. Right? So this is like 0.3 plus 0.08. So it gives us 0.38, and there it is, 0.3520. Right? That's the area under this curve. It's also the probability, right, of, well, can't do that. I don't know my mean and standard. Never mind. It's just the area under the curve. Okay. All right. Find the area under the standard normal curve to the right. Okay. So this time, our z value is 1.25. Okay, so 1.2, 0, 1, 2, 3, 4, 5. Get my pen here. Okay, but that's not our z value because this time it says to the right. Okay, so, okay, here's our mean, standard deviation. That means at 1.2, we want to know this instead of this. This number is giving us this area, but we want to the right of that line. So we're just going to say, okay, the probability that x is greater than 1.25 is the probability that X is, I was right this first time, it's 1 minus the probability that X is greater than 1.25. So that's 1 minus the 0.8944, right? Okay, where's my calculator? 1 minus 0.8944. Okay, so 0.1056. So pay attention to if we want the right or the left. Okay? Okay, for the IQ model where the mean is 100. Oh, sorry guys, that's my phone. Let me get my phone and shut it off. Yeah, sorry. Okay, where were we? Okay, for the IQ model where the mean is 100 and the standard deviation is 15, find the probability that a person has an IQ between 120 and 150. Hey, if I have the actual mean and standard deviation, I can use my calculator. If it just gives me the z-score, I've got to use the table. Now, I could also use the table for this, but hey, let's use the calculator, right? All right, so once again, we would hit second VAERS. Where am I? Okay. To get to our distribution, go down to the normal cumulative distribution. And I want to go between 120 and 150. So 120, comma, 150, comma, mean of 100, comma, standard deviation 15, comma. Okay. So the probability, okay, that we are between 120 and 150 is 0.0908, right? Just barely over 9% of people have an IQ between 100 and 150. Okay? So if we randomly selected 100 people, we'd expect about 9 of them to have an IQ between 120 and 150. Okay? All right. Find the area under the standard normal curve between z equals negative 1.02 and 2.94. All right, I can't use my calculator on this one. It's just giving me the z-scores. So what I need to do, because it said it's normal, I'm going to draw that curve. Okay, where this is 0, and then we've got 1, 2, 3, because we're using z-scores, negative 1, negative 2, negative 3. Okay, and it wants us between z is negative 1.02. So that's like right here. Negative 1.02 and 2.94. So that's like right here. And we want this area right here. Right? That's what we need. But that table only gives us strictly to the left. So what it's going to give me is it's going to give me all of this area if I look for this value. And when I look for this value, it's going to give me this area. Now, how can I just find this area from being able to find this area and this area? You got it. Find this area and take this one off, right? So once again, just to show the area involved instead of those lines that's going outside, okay? The table value from here is going to give me this area. And the table value from here is going to give me this area. So if I have all of this area and I take off this bit, I'm going to be left with what I need. Okay, so I don't have the table up here on this one. Couldn't find a convenient one that had both of these values. So if you're working along with me, you need to look at that table that I put under your course information and documents module. Okay, so I'm going to look at z equals negative 1 point. Let's go up here first and see what we're doing. So we're going to say z equals negative 1.02. So negative 1.0. Oh, let's find this one first. 2.94 so that I can subtract in the right order. So 2.9, I'm going down to my table, 2.90123.4 is 0.9984. So that's all this area in gold, all of it. But I don't want all of the area, I just want this part. So I'm going to take off, now I'm going to look at negative 1.02, negative 1.0012.1539. Okay, so that's this area I've marked in black. So take it off. 0.9984 minus 0.1539 for a final answer of 0.8445. Right? That's the area under the curve that is all of this, just this part. Okay. Whoops. All right, Wendy's drive-thru. Fast food restaurants spend quite a bit of time studying the amount of time cars spend in their drive-thrus. QSR magazine studied drive-thru times for fast food restaurants and found Wendy's had the best time, with a mean time spent in a drive-thru of 185 seconds. Assuming drive-thrus are normally distributed, gotta know that, with a standard deviation of 29 seconds, woohoo, it gave me the mean and the standard deviation calculator. What's the probability that a randomly selected car will get through Wendy's drive-thru in less than 100 seconds? All right, so remember, to help us with an understanding of this, you might want to always draw your graph. So let's see, I'm looking for the mean, 138.5. Okay, and then if we add 29, we get 167.5. And if we subtract 29, we get 109.5. I know we can't read those numbers up there, but we know this is the mean and the first standard deviation. All right, so we're looking for less than 100 seconds. Less than 100. Oh, this is 109. We're looking for this area, which is exactly what either the chart or our calculator will tell us. Now, we can do a second enter to get that information back up so that we don't have to keep going into that menu, right? And then just type over what you want. So we want less than 100 seconds. So that's 0 to 100. That means if it just says less than 100, if it doesn't give me two values, right? Then I'm saying, oh, okay, all the way to 0. And then the high value would be 100. The mean is 138.5 with a standard deviation of 29. Okay, 0.0922. What's the probability that a randomly selected car will spend more than 160 seconds? Now, here's 160 something. So this time, we're looking for more than, we're looking for this. Okay? Remember, our calculator and our charts is going to give you this number. So use the complement rule. It would be 1 minus whatever you get this to be. Okay, the entire area minus this bit. Okay, so I can just hit second enter. Okay, and this time I'm still going from 0 but to 160. Okay, so I get 0.7708. But remember, that's this area. So 1 minus that is 0.2292. Okay, what proportion of cars spend between 2 and 3 minutes in Wendy's drive-thru? Now, I've got a caution statement here. See if you can tell what it is that you have to be careful of. Yep, minutes, and our information is given in seconds. So I have to convert this to 2 minutes is 120 seconds and 3 minutes is 180 seconds. 60 times 3, 60 times 2, right? All right, so now, okay, instead of 0, I'm going to put 120. And then 180, and then I already have my mean and standard deviation in there. So 0.6620. Okay, would it be unusual for a car to spend more than 3 minutes in Wendy's drive-thru? Well, more than 3 minutes, that's 180 minutes. So that would mean this part. Is that unusual? Kind of looks like it from the graph, doesn't it? But let's see. Now remember, our calculator or our chart is going to give us this part. So we've got to do 1 minus. Now let's enter that information. I already have the 180 in there. I just have to change the 120 to 0. Okay. 1 minus, here's what my calculator gave me, 0.9238. So that is 0.0762. Would it be unusual? No, because remember, unusual less than 5%, and this is over 7.5%. Okay, here's some cautionary thoughts, right? Remember, this normal curve extends indefinitely in both directions. So for this reason, there's no range of values for which the area under here can ever actually equal 1. Right? So calculators might state the area is 1, because it can only compute to a limited number of decimal places, right? There's that rounding issue again. However, the area will be some value slightly less than 1. So if your calculator ever gives you a value of 1, your actual answer is really going to be 0.9999, right? Okay, notice how that rounds to 1 anywhere you want to round it. Okay, really it's 0.9999, and when you round this to this, you would get all the way over to 1. Okay. Similarly, if it reports an area as 0, you're really going to call that. So if it tells you you get a 1, but if it tells you you get a 0, you're really going to call that 0, 0, 0, 1. Okay? If you're finding your area from the table, okay, notice that the biggest number is 3.49 and the smallest number negative 3.49. So we're going to use the same context. If you're going anything bigger than anything bigger than 3.49, it's off the table and you'll use this value. Anything smaller than negative 3.49, which would be off the table, you'll use this value. Okay? Okay, often we don't want to find the proportion, probability, or percentile. Rather, we want to find the value of a random variable that corresponds to a certain proportion, probability, or percentile. For example, we might want to know the height of 3-year-old girl who is at the 20th percentile. You know, what would that height be if she's at the 20th percentile? Or we might want to know what's the score that you got to make on a standardized exam to be in the 90th percentile, right? What's that score that correlates to that? Okay, so here's a procedure for finding the random value of a normal random variable. Okay, draw the normal curve, shade the area corresponding to the proportion, probability, or percentile that you're given. Use a table to find the z-score that corresponds to the shaded area. And then I'm going to mark this out. It says obtain the normal value from this formula. Where this formula came from, it's your z-score formula. They've just solved it. But I don't want to recognize. I don't want to remember an extra formula, right? So notice if I solve this formula, if I multiply both sides by sigma, then I get sigma times z equals x minus u. So add u. Okay, so that's just where that came from. But I'm not memorizing an extra formula. This is the formula I need. And if I have all my information except x, I can solve for that value, right? All right, so this says the combined verbal and quantitative reasoning score on the GRE is normally distributed with a mean of this and a standard deviation of that. Okay, so what's the score of a student whose percentile rank is at the 85th percentile? Well, let's figure out what that means. Okay, and again, normally is why I draw this. Anytime it says normally, I'm drawing this. Okay, here's my mean. Okay, so I'm going to add 189. $12.38. I'm going to add 189. $14.27. I'm going to add 189. $16.16. Then I'm going to go back to 1049. I'm going to subtract 189. $8.60. I'm going to subtract 189. $6.71. I'm going to subtract 189. 482. Okay. Now, we want the 85th percentile. I'm also going to put 0, 1, 2, 3, -1, -2, -3. And then I'm going to go to my chart, and I'm going to look for 0.85 on my chart. Okay, so there's the 0.78. Okay, right across 1, I've got 0.84, and 1.1 is 0.86. So I'm going across until I see 0.85. All right, I see 0.8. Let me write them up here. Sorry, I just never have room to do what I need to do. All right, so I see 0.8508 and 0.8485. That's at, so 8508, here's my choices. I go from 0.8, the chart goes from 0.8485 to 0.8508. And I'm looking for 0.85. That is closer to this than this. So 0.8508 corresponds to 1.001234. 1.04. Okay, so let me go down here. 1.04. That's like just barely past that 1. Okay, 1.04. So I can expect my number better be somewhere just over 1238, right? Just a little bit over 1238. Okay, so I know my z-score is 1.04. Let me get a different color here. Okay, I'm using this formula. I know my z-score is 1.04. This is what I'm looking for. I know my mean is 1049, and the standard deviation is 189. So let's solve that. Let's multiply 1.04 times 189. So I got 196.56 equals x minus 1049. So let's add 1049 to both sides. And I get x is 1245.56. Does that make sense? Yeah, I believe that. I trust that. That sounds good. Okay, so a person who scores, 1246 on the GRE would rank in the 85th percentile. Okay? Okay. It is known that the length of a steel rod is normally distributed with a mean of 100 centimeters and a standard deviation of 0.45 centimeters. Yay, I have my mean and standard deviation. Suppose the manufacturer wants to accept 90% of all rods manufactured. Okay? Determine the length of rods that make up the middle 90% of all rods. Okay, whoops, let me get my pen. All right, because it's normally distributed, I can do this. Mean is 100, right? Standard deviation 0.45, so 100.45, 100.9, and 101.35. And then 100 minus 0.45 is 99.55. Minus 0.45, 99.1. And minus 0.45, 98.65. Okay, remember that's also if we use z-scores. Okay, but what this one is asking is it wants to know the middle 90%. That means this part here needs to be 5%. And this part here, some part, I don't know yet what part, but that's what my graph would look like, right? So I need to take off the top 5% and the bottom 5%, because the entire thing's 100%. That would give me the middle 90%, right? So first, let's find the z-score that corresponds to about 0.05, right, on the left, right here. Because our z-scores are less than, let's do this one first. Less than, let's look on our chart for 0.05. Okay, so around between negative 1.7 and 1.6, it goes from 0.04 to 0.05. So let's go down to 1.7, and I get, nope, let's go down 1.6. Okay, and I get two values at, I get 0.0495, and I get 0.0505. 0.0505. Okay, 0.05 is in between here. Ooh, notice this time there's not one that's closer. It's exactly halfway in between. Last time we just chose the one that was closer to the value we needed. What was it, 81 or 89 percentile? 85 maybe, whatever. If it's exactly halfway in between, average them. Find what is exactly halfway in between. Okay, so let's do this. 0.0495 plus 0.0505. Not this. I know what's halfway in between there is 0.05. Duh. Okay, I want to average my z-score. So let me go back to the 04. Where did I find that at? I moved my marker. Okay, so 0.0495 corresponds to a z-score negative 1.65, and 0.0505 to negative 1.64. All right, so I'm going to go halfway in between there. All right, so I'm going to add them up. And divide by 2 to get, if we didn't already know, negative 1.645. Okay? Now, I'm going to do the same thing with this 5%. But once again, think about if this entire thing, I should have put that over here and I'm going to do that. I'm going to move this over here. Okay? Let me go back to red because I'm going to put it over here. 0.0495 corresponded to negative 1.65. 0.0505 corresponded to negative 1.64. So negative 1.645. Okay, so that represents that 5% on the left-hand side of the graph. Over here, Okay, if I want this 5%, remember my graphs, my charts, and calculator always go to the left. So I'm going to find 0.95, right? I'm going to flip this to 0.95 instead of 0.05. This is 1 minus 0.05, right? So this is really what I'm looking for on my chart. So 0.95. When I look at 0.95 on my chart, I've got a 0.94, 95, and a 0.9505. Again, exactly halfway. So 0.9405 corresponds to 1.64. And this one corresponds to 1.65. So because it's halfway in between, I'm going to average again. Hey, did you notice anything? Oh, yeah. You know what? Since we're talking about 5% on both sides, and because it's symmetric, I could have used that information once I found one of them. So keep that in mind. Right? Okay. Now that we have found these two values, okay, we want to check. I'll do it in here. Okay. So let's say x sub 1, okay, is going to be my mean. It's my mean, 100. Okay. Plus negative 1.645 times let me see. Let me get rid of that and go back to okay, we know what our z-score is. It's maybe we know what our z-score is. Jeez. Okay. I'm sorry guys, but I lost myself there for a minute. It's x minus mu over sigma. Okay, so if I know my z-score is negative 1.645 and my mean is 100 and my standard deviation is 0.45, then I can solve for x. Okay, so negative 1.645 helps if your calculator's on to be useful. So turn your calculator on. Negative 1.645 times 0.45, right? Getting rid of the fraction and add 100. All right, so we get 99.23. Okay, and let's do the other one. if we have 1.645 equals x, let's call this sub 1, sub 2 minus 100 over 0.45. So 1.645 times 0.45, 0.74025 equals x sub 2 minus 100. So let's add 100. So x sub 2 is 100.74. Okay, the lengths of rods that make up the middle 90% then are 99 centimeters to 100.7 centimeters. Okay, 101, wherever you want to round to. Okay, so I hope that made sense, because I lost what I was doing there for just a minute. Okay? All right, if you have questions on that, be sure and let me know. Okay, so in the upcoming chapters, we're going to need to find the z-score that has a specified area to the right. So we got a special notation to represent this situation, and it is called z sub alpha. Okay, and that's alpha, that's the alpha symbol. Oh, there's a better representation. That's a little hard to tell what it looks like, but you know, another Greek letter, alpha. And whenever you see a z with a little number down here, it means it's talking about to the right. If you just say z-score, it's this area. If it's z sub alpha, it's the area under the curve to the right. Okay, so it says find the value of z sub 0.1. Okay, so it's, let me get my pen, it's the area to the right. So once again, I look on the table, and let's draw it again just to get an idea. This drawing is really going to help you. Okay, so 0, 1, 2, 3, and 0.1 is like right here. So it just kind of helps me get an idea if I draw what I'm looking for. So if I'm looking for everything to the right, okay, I'm going to look on my table for that value of 0.1 again. 0.1. And I see that, okay, 0.0985 corresponds to a z-score of negative 1.29. And then 0.1003 corresponds to a z-score of negative 1.28. Okay, this one is closer to 0.1. So I'm going to use that 1.28, right? So it's really specifically my z-score is negative 1.28. Okay, and that's all that means. You've got a couple of questions on your homework this time where it just asks find this z sub alpha. So that's all we do, right? Just look on your chart, find the z-score corresponding to this number. And then we'll talk more about it later. Okay, that's all we're going to do in chapter 7. So let me know if you need anything.